next we have Patrick Kelly and Salem Amazet, who is the head of field engineering and senior director from Databricks, presenting distributed clean rooms powered by encrypted computation. They'll explore how encrypted computation can enable secure data collaboration and analytics without compromising privacy in large-scale settings and distributed environments. Please welcome Patrick and Salim from Databricks.
I just want to get started. Yeah, so I'm Patrick. I lead the sales team for Southeast Asia for Databricks.
Yeah, and I'm Salem. I lead the technical pre-sales team for Databricks, working with Patrick.
Perfect. So the problem we are solving actually is something which Pramod touched to a certain extent. And the problem is, how do we create a trust list by design, distributed clean rooms? So clean rooms have been very popular. Databricks has been one of the big players in that domain, selling clean rooms to multiple partners. And the attempt here is to just discuss how we can provide more power to clean room using encrypted computation. So a clean room currently is being used for federated sharing. Private libraries are getting deployed across different infrastructures and use cases. And it creates multi-party collaboration environment, and then it opens a plethora of business opportunities. And it has built-in governance, let's say in Databricks environment as well. So there's a powerful tool out here, and multiple use cases in identity, collaboration in real time between retail and suppliers, FMCGs, decision-making, KYC, and many more. And these all are actually solving some real problems in corporate business collaboration. And this is how traditional database clean room works in Databricks setting. You have a collaborator, and then you have a collaborator A and B, and then the clean room where you connect data, the well-defined protocols based on delta sharing, which ensures data is not copied. And then inside a clean room, which is a protected environment, you do all the analytics. But in multiple cases, we do require more guarantees, more trust. Because if there are data movements, some cases, because of land localization laws, because of privacy regulations, they might insist that let's not move data actually, to remove any centralized trust, and then use those arguments to get regulatory acceptance. And this is what we are targeting by adding cryptographic primitives on top of clean room. So no data movement, immutable audit trail, and cryptographic guarantees. And then it can open up multiple cases, which we talked about, like cross-border fraud detections and many more. So the techniques we are using right now is based on multi-party compute, largely, which is a fundamental way for multiple entities to collaborate without actually moving data around. And the popular functions inside are secure mass, secure stash, data restructuring, and a couple of others. And these are just popular ones, but fundamentally it can do a lot more than this. So what's exactly happening here in terms of Databricks trustless cryptographic clean rooms? I will hand over to you.
Sure, awesome. So we think about data sharing or sharing data in two ways. We've got Databricks Marketplace and Databricks Clean Room. I think even before we think about data sharing, I think a lot of topics this morning was talking about that. But I think even a lot of companies, big enterprises, haven't even organized their data internally. So they don't have a good idea of governance of assets, management of assets, even sharing data between different business units. We find that's still a big problem. So we've worked with a lot of customers to really implement a governance strategy across their business, and then they can take that externally. And Jay mentioned it around the delta sharing, right? So if we look at these two angles, if we think about the marketplace, so basically it's an open marketplace, all your data analytics, we've got different providers like London Stock Exchange, S&P, Moody's, etc. And they can then share these data sets to all the different consumers who can then evaluate, build them into their data products and build them even faster. I think just as we finished off the last topic, talked about, I mentioned AI already, but we've just launched like MCP on Databricks Marketplace. So not MPC, but MCP, so the Model Context Protocol for managing agents. So how an agent can interact with data within your organization. And different providers we've signed up here that their MCPs are now accessible through Marketplace as well, which is pretty good, just only like last week. So lots of things to go on there. And then from clean rooms, just very, very high level. So Databricks, we operate on any cloud, so all the big hyperscalers out of the US, any language, any workload, so whatever SQL or Python or Scala or Java, whatever else, will work with that as well. And then really scaling across multiple parties, complex workloads, orchestration, etc. And then an example. So MasterCard, who have really signed up for us on clean rooms. So sharing data today through FTP is not ideal, right? So how they've leveraged clean room for this. So especially around fraud detection, anti-money laundering use cases, and then in marketing. So how do they measure marketing attribution across different campaigns to be able to share that with their, so they have a credit card or with a retailer or with some kind of loyalty program as well. How do they share that all safely and security? So we just really launched that, but a lot more to come on how MasterCard are going to leverage that. And I'll pass over to Salem to tell you how it works. Yeah.
Thank you. Yeah, so from a technical perspective, so yeah, just as Patrick mentioned, in the past or even today, still a lot of companies rely on the FTP, SFTP, FTPS, and not very secure way or ways that are loved by regulators to share data, right? But still, this is answering requirements around owning the infrastructure and being able to audit and being able to know what's going on when sharing that data, right? So the clean rooms really is a way, modern way to share that data between different parties, and it's loved by customers that have regulatory requirements and that are more advanced in the way they deal with their infrastructure, right? So how does it work from a technical perspective? So on the Databricks marketplace, that's where, as a Databricks customer, you can select specific services from third-party providers like Silence Computing. And with Silence Compute, basically, you have a cryptographic way on VMs to massage the data and put that data to good use with third parties, right? So that will allow different parties, different collaborators to exchange data with a proof of compute that is cryptographically safe, right? And the setup is very easy. There are different scenarios and process flows, right? So you have two organizations that want to enrich their respective data sets, and they can do that through the marketplace and of Databricks and Silence and the clean rooms, right? And they don't want to expose or transfer the data outside of their own environment, right? And also they don't want to copy that data on a different environment, right? So yeah, so if we move to the next slide. So there are different designs to achieve that. So the first one is silent compute on Databricks marketplace. So basically when the different parties don't want to use a neutral middleman or provider to exchange the data. So the collaborators from the marketplace will exchange that data through API by connecting their data set from their own database. So they don't really copy the data. It's already there, just made available to the collaborator B, right? And the collaborator B will do the same. And that's then will initiate a request to enrich or look up both data sets in a secure manner directly from the collaborator's environment, right? And if we move to the next slide, the second design, which is using the Databricks clean room. So in that scenario, we have a neutral provider, which is Databricks, that will help with sharing the data. And in that case, we have to create a clean room. So the collaborator B will create a clean room here, and then we'll add the other collaborator as a sharing partner and giving them a sharing identifier, right? And then the data set will be provided through the clean room, and all the access is audited, all the access is controlled via the Databricks platform, via the clean room, via other products like Unity Catalog, where all those assets are controlled and audited. And then the output will be displayed in the collaborator A for usage, right? So you have those two different ways to access when you need total confidentiality without a neutral platform, and when you can use a neutral platform to share that data, right?
Right. So yeah, this is just a picture of how large-scale enterprise setting and solutions like Databricks can work with a privacy tech to enable secure collaborations. And a couple of problems which Pramod and others mentioned can be solved. So essentially, having clean rooms with more privacy guarantees using cryptographic computing. That's what we talked about. And the goal is to serve market demands, particularly coming from insurance, financial institutions, largely working in cross-border setting, because that's where the privacy requirements are much more higher. And that's our goal, to make it much more usable. And yeah, let's open up more and more use cases. Yeah, thank you very much for listening.
Thank you.
Thank you to Patrick and
Thank you.
Thank you.
Thanks.